This is matrices lesson number 1, and the aim for this day is using something called Gaussian, Gaussian, elimination to solve a system of 3 equations and 3 unknowns. And for the do now, I'd like everybody to do two 2x2 systems of equations. So the first one is 2x plus 3y equals 9, and 4x plus 5y equals 17. This is just a review question. The easiest way to do this question is to multiply the top equation by -2 to get -4x minus 6y equals, don't forget to multiply this by -2 also, -18. We do that so that the x's have opposite coefficients. Now we can combine these two equations to get -y equals -1, or y equals 1. And when you plug that y value into any of these equations, I'll plug it into this, seems like the easiest. 2x plus 3, y is 1, equals 9. So 2x, subtract 3 from both sides, 2x equals 6, x equals 3. So the solution, the ordered pair is 3, 1. So that was the first question. But now the second do now question is a bit more complicated. Do now question 2 is, what if everything was a variable? Ax plus by equals c, and dx plus ey equals f. So we want everyone to do both of the do now questions, to spend some time on them, give them about 6 minutes, 6 or 7 minutes, because this question 2 takes a while. To do question number 2 is difficult. We want to eliminate the, I'll say, let's eliminate the y. To eliminate the y, we have to multiply the top equation by e and the bottom equation by b. So you'd get aex plus bey equals ce, and on the bottom you'd have b dx plus bey equals bf. I'm putting these in alphabetical order just to so that we can see when things are the same. If I subtract these two equations, these would cancel out, so you get aex minus bgx equals ce minus bf. Factor out the x, ae minus bg equals ce minus bf. Divide both sides by ae minus bg, ae minus bg, and we get our answer for x. Let's not worry about what y is. In fact, when you do this question, just say solve for x. Probably be easier to redo the question to eliminate the x to solve for y rather than try to plug this big thing into the original equation. So that would be the do now. Doing that and having them do it and going over it probably takes about 15 minutes. Then we get into the actual lesson itself. Let's take a look. For this lesson, we want to go over again how to solve a system of 3 equations and 3 unknowns. Now, we did 3 equations, 3 unknowns back when we were studying parabolas and finding the equation of a parabola that goes through 3 points. Those equations, though, were easier than the ones we're going to do today. Those always had plus C, and plus C, and that made them kind of a little bit less work. We want to learn how to do it more generally. So the goal is to find 3 numbers, x, y, z, an ordered triple that would satisfy, so the x, y, and z would satisfy all of these equations. And the general process is to somehow convert this type of system of equations where you have 3 equations and all 3 equations have all 3 variables into it, into something that I'm going to call an upper triangular system. And what an upper triangular system is a system of equations where the top equation has all 3 variables. The second equation only has 2 of them, so it doesn't have that x term. And the third equation doesn't have an x or a y, but just has a z. So this is sort of our goal. I'm going to teach you how to, or someone's going to teach you, how to take these 3 equations and convert them into these 3 equations. If you can get something like this upper triangular system, it's called that because this looks like a triangle now. If you can accomplish that, it's very easy to finish the question because the last equation is just one of the answers. Then you could take that z equals 2 and plug it into the middle equation. 2 equals negative 10 over 3. Y plus 2/3 equals negative 10 over 3. Gives us y equals negative 12 over 3, which is negative 4. And then we can plug the 2 and the negative 4 into the original equation. X plus 2 times negative 4 plus 2 equals 3. This is minus 8 plus 2 is minus 6 equals 3. Gives us x equals 9. So the answer to the question is going to be 9 minus 4 and 2. But what I'm going to teach you now is how to convert a system of equations like this, which is not upper triangular, into a system of equations like this, so that the last equation just has z in it, the middle equation has y and z, and the top equation has all 3. The order that we're going to remove these variables is first we'll somehow find a way to make this 2x here go away. Then we'll turn this x into a 0 somehow. And then finally we'll turn this y into a 0. And in doing so, everything else is going to change, but what we'll be left with is one of these upper triangular systems. Now, there are 3 sort of rules that we're allowed to do. One thing that we're allowed to do is we're allowed to take any of these equations. I'll call this equation 1, equation 2, equation 3 for reference. One thing we're permitted to do is we are allowed to switch any 2 rows with each other. So that's something that's allowed. It does not change the answer to the question. Whatever the 3 answers are, they'd be true regardless of which thing we call row 1 or row 2. Another thing we're permitted to do is we're allowed to take a number, any number, a constant, multiply it by a row, and substitute that for the actual row. And this is what you do when you do the 2 by 2 system and you multiply the equations by something. The third thing we're permitted to do, and this is sort of the most confusing one, is we are allowed to multiply a number by a row, add that row to another row, and replace that other row with that sum. And I'll go over how these work within this equation. But those are the three things we're allowed to do. So let's see how this applies to this question. I'm going to work one column at a time, so I'm going to start by working with this column. First thing to check is, does this x have a 1 in front of it? And since it does, we can skip right to the second step. If this wasn't a 1, if this was like a 2, we'd multiply the entire row by a half to get things started. But this is a 1 already, so that's good. Now, the most popular rule to use is rule number 3. So what I'm going to do, I'm going to use rule number 3. Here's rule 3. In order to make this 2x get eliminated, I would have to multiply the top row by -2, or equation 1 that is. So multiply the top row by -2 and then add it to equation 2 and put the answer into equation 2. I'll indicate it this way. So -2 equation 1 plus equation 2 is going to go into equation 2. Now, one thing to keep in mind is that even though I'm going to multiply equation 1 by -2, I'm not going to change equation 2 in this system. So I'm going to leave it alone, but that multiplication is going to happen in the getting rid of this second row. So now equation 3 is not going to change either. So only one equation changes each time. So I chose -2 because -2 being the opposite of regular 2, when I multiply that by 1, this would become -2x, add to this would become 0. So now I'm going to do the 4 elements here. 1x times -2 is -2x plus 2x is 0, just like I wanted. -2 times 2y is -4y plus y is -3y. -2 times z is -2z plus z is -z. And don't forget this part, -2 times 3 is -6 plus 16 is 10. And now I've accomplished one of the 3 steps I needed to do in order to make this thing be triangular. Okay, that's almost 15 minutes, so I'm going to pause this lesson